Myself is ANUJA, assistant professor. The subject is fundamental of embedded system. So today we discuss the introduction of fundamental of embedded system. What are the syllabus? Is what we learn in this subject. And first we require the free request knowledge of the for the subject. So first we require knowledge on semiconductor and microprocessor and microcontroller, and coming to the subject objective, the first objective is understand the embedded system and its application, and learn different embedded embedded processor and their architecture. And third objective is analyze the embedded architecture, quantity and their security concern. And the last one is design, implementation and testing on embedded system. These are the course objectives we discuss in this subject. And next, coming to the course outcomes. First, in this course we learn some course outcomes. First one is understand the processor involved in design of the embedded system, and the second one is draw and analyze the system clock with design consideration and test generation of methods. And the next one is understand the different types of memories. And next one is understand the embedded firmware design approaches. The last is gain the knowledge of task communication. These are the course outcomes we are getting the knowledge from this subject. And coming to the syllabus of the fundamental of embedded system, first unit, it consists of 5 units and its credit is 3. So first unit is introduction of embedded system, and the unit name 1. In the topics is definition of embedded system, classification of embedded system, and purpose of embedded system, major application of embedded system, characteristics of embedded system, and quality attribute of the embedded system. These are the topics covered in unit 1. And second unit is unit 2, the typical embedded system. And in the typical embedded system, again we discuss application specific integrated circuit, that is ASIC, and PLDs, programmable logic device, and memory. In memory, again we discuss RAM and ROM memory according to the embedded system interface, sensors and actuators. And the last topic is communication interface. These are the topics we covered in the unit 2. And next is unit 3. In unit 3, in embedded system, first we discuss embedded firmware. Okay, and next one is watchdog timers, reset circuit, brown note protection circuit, and real-time clock, and the difference between embedded C and C language. These are the topic we covered in third unit. And coming to the fourth unit, unit 4 is real-time operating system based on RTOS embedded system. Here we discuss design approaches of RTOS and architecture of RTOS, and types of operating system, and task, process and threads, task, process and threads. And the next topic is multiprocessing and multitasking. The last topic is task scheduling. And the next one is booting process of OS. These are the topics we covered in fourth unit. And coming to the fifth unit is task communication and shared memory, message passing, pipes, and task synchronization issues, remote procedure call, socket, and device driver, Linux basics and utility of Unix, Linux, Windows. And next one, advance of Linux and Linux device driver, and role of device driver. These are the topic we covered in unit 5. Okay, so today we some textbooks are there for this subject. The textbook is Shibu Introduction of Embedded System, edition is 2027, and second edition is Morgan Kaufman, Computer as a Component. This is a edition in 2019, and the reference textbooks are there, Raj Kamal and so on. So coming to the definition of embedded system is a electromechanical system and designed to perform a specific task and is a combination of hardware and firmware. Firmware is nothing but software and it perform a specific task. This is the embedded system definition. Here the program executions are stored in a software format or program form. So we can store the memory is flash memory is a commercial embedded system. And here we can see the various embedded system examples like your washing machine and you have micro oven, digital TV, digital set-top box. We can see digital traffic signals, and all those are examples of embedded system. And the next one is general purpose computing and embedded system. What is the difference between general computing and embedded system? Here we see the difference. First one is a general purpose computing and second one is embedded system. General purpose computing system is also a combination of hardware and software and general purpose operating system for executing a variety of application. But whereas in embedded system is also the combination of hardware and software and it performs a specific task. And second difference is the general purpose computing system contain operating system, whereas in embedded system it may contain or it may not be contained as a operating system. The second one is the third one application is applications are alterable, where in the general purpose embedding general purpose computing system applications are alterable, whereas in embedded system applications are not alterable. That means whatever the program is there in the embedded system, that is a fix, we can't change depending on the user, where in general purpose we can change, we can alter the program, but in embedded system we can't change. Okay, next one is less not all the tolerant towards the reduced operating power requirement, options for different level for the power management. In the general purpose computing system the power consumption is very large, and whereas in embedded system the power consumption is very less. In terms of power, embedded system required less power. In terms of general purpose system the power is required more. And the next one is response requirement is not critical in the general purpose computing, whereas in embedded system response is very critical. And in next is need to not a deterministic in nature. The general purpose computing systems all are not need to a deterministic in nature, whereas in embedded system all systems should be need to be a deterministic in nature. These are the difference between. In the example you can see the general purpose computing, your desktop, your PC is the example of general purpose computing, whereas in embedded system washing machine, micro oven, we can see these are the embedded system example. And next, classification of embedded system. Embedded systems are classified into 4 groups. First one is based on the generation, and second one is based on complexity and performance. The third one is based on deterministic behavior, and the last is based on triggering. Again the generation classification of generation, again here we are the first generation, second generation, third generation, fourth generation. And second classification of embedded system based on complexity and performance, again we have subcategorized here small scale, medium scale and large scale. Based on triggering behavior, again it classified into hard real time and soft real time. Based on the triggering, it is a event trigger, time driven trigger system and hybrid system, and each one we discuss in detail in this slide. So first classification of embedded systems are 4 types. based on generation, complexity and performance, and deterministic behavior, and based on triggering. So first generation embedded system. The earlier embedded systems were built around 8-bit microprocessor and 4-bit microcontroller like 8085, and this is a microprocessor, and Z80 is a microcontroller of 4-bit microcontroller. The example of first generation devices are digital telephone keypad and stepper motor control unit. These are the example we can see in the first generation embedded system. And next, coming to the second generation embedded system, these generation of embedded systems are designed 16-bit microprocessor and 8-bit microcontroller and follow same as the first generation embedded system. And the difference is here we are introducing the instruction set for the second generation of the microprocessor and microcontroller, so that the much complexity increases. Based on complexity, the performance of the system is increased. The example of second generation systems are data acquisition system and SCADA system. The third generation of embedded system with the advanced processor technology coming in the in this industry, and in the industry of embedded system, we develop 32-bit microprocessor and 16-bit microcontroller, and their design are again contain the instruction complexity. So based on the complexity, the performance is increased. The example of third generation is digital signal processing and application specific integrated circuit. All these are example of third generation. And coming to the fourth generation, the fourth generation of embedded system with the system on chip architecture with advanced reconfigurable and multiprocessor and multi-core are being high performance and tight integration and minimization into the embedded device market. And SoC techniques are implemented a total system on chip by integrating different functionality within a processor core on a integrated circuit. And the fourth generation embedded system, the example we can see here, all industrial robot and all flight applications we can see in the fourth generation of embedded system. And next classification is small scale embedded system. Next classification is complexity and performance based. In that again it is classified into 3: small, medium and large. So first we see small embedded system. Small scale embedded system built around low performance and low cost 8-bit microcontroller and 16-bit microprocessor, and it's suitable for only small and simple application, and it is not a time deterministic in nature, and it required only some critical functionality. And the small scales in embedded system, it does not contain any OS. Next, medium scale embedded system. Medium scale embedded systems are built around 16-bit microprocessor and 32-bit microprocessor and 16-bit microcontroller. These are slightly complex in hardware and firmware. It may contain the OS. The large scale embedded system. The large scale embedded systems are built high performance, that is a 32-bit microcontroller and 64-bit microprocessor, and with instruction sets such as RISC, reduced instruction set processor and controller, SoC system on chip architecture, and multi-core processor and PLDs. These are the processor we are used to implement the large scale embedded system, and it required complex hardware and software. Those system may contain multiple processor and multiple controller and co-unit hardware and accelerator of offloading processing requirement from the main processor. It contain real-time operating system for the scheduling, prioritize and management of the task activity. And the last one, the next classification of embedded system is based on deterministic behavior. In that, again, it classified into soft real time and hard real time. In the soft real time, the missing deadline may not be critical and can be a tolerant at a certain degree. And the hard real time of embedded system, missing a program task and execution time deadline can be a category and consequence. Example is the financial human losses of life, etc. We can see the examples of hard real time and soft real time. Example, while we watching the movie, at the time some buffer is occur, so that buffer we can call a soft real time embedded system. And next classification based on the triggering, event trigger and or event trigger or time trigger is known as or trigger. And event trigger, the activity within the system or dynamically and depend upon the consequence of a different event. This is called event trigger. And time trigger, the activity within the system follow a statistical or computable schedule or task schedule, and they allowed for a time slot, and those activity we can call as time triggered activities.